Hello and welcome to my channel. I'm Sam Augustine. Please, if you're new here, kindly subscribe to my channel. And if you have been watching my videos and you've not yet subscribed, please kindly subscribe for us to build the mathematics community. Thanks to Ebenezer Tete, also known as Piano Lessons from the University of Ghana, Legon, for sending me this question. Now let's go to the question. Use the definition of natural logarithm so that for x greater than 0, 1 plus x times natural log of 1 plus x is greater than x but less than x times 1 plus x. Hence, show that natural log of 1 plus x is greater than x minus x squared plus x cubed minus x to the power 4 plus dot. And that as x approaches 0, natural log of 1 plus x divided by x approaches 1. Now, remember to subscribe, like, share, and leave your comments. Now, what do? We have natural log of 1 plus x, so let's define that. From the definition of natural logarithm, natural log of 1 plus x is equal to the integral 1 up to x plus 1 divided by t dt. Now, this implies that 1 is less than t less than x plus 1. That is, t lies between 1 and x plus 1. Look at this. 10 is less than 100, but 100 is less than 1000. Right, but let's turn this upside down. 1 over 10 will be greater than 1 over 100, which will also be greater than 1 over 1000, because this is 0.1, 0.01, 0.001. Wow. So, we are going to do the same here. We are going to turn each upside down. So, first turn is 1 on t to be greater than 1 on x plus 1. This is 1, so if you turn it upside down, it will still become 1. Wow. Very simple as that. Very simple. Sure? It will be this zero. Yes. Like what we've done to be this. So let us arrange it properly. So now 1 on x plus 1 is less than 1 on t. And this 1 on t is also less than 1, because 1 is greater. Very simple. Now let's integrate this by integrating each term with respect to the t from 1 up to x plus 1. So you have the integral from 1 up to x plus 1, because t lies between 1 and x plus 1. So you have 1 on x plus 1, the t is less than the integral 1 to x plus 1 on t, the t less than the integral 1 to x plus 1 of 1 dt. Now 1 on x plus 1 is a constant. So we take 1 on x plus 1 out to the integral 1 to x plus 1 dt less than the integral 1 to x plus 1 on 1 on t dt, which is also less than the integral 1 to x plus 1 dt, because 1 times dt is dt. So now let us integrate. If we integrate dt with respect to dt, we get t. So you have 1 on x plus 1 t, then the lower limit, upper limit, less than. You integrate 1 on t, you get natural log of t. So you bring the lower limit and then the upper limit, less than. If you integrate the t, you get t. So you bring the lower limit and then the upper limit. So now you have 1 on x plus 1 times upper limit minus lower limit less than natural log of upper limit minus natural log of lower limit, which is less than upper limit minus lower limit. So we are going to have here 1 minus 1 is 0. So you have x divided by x plus 1. That is, x times 1 will give us x. Less than natural log of x plus 1. For natural log of 1 is 0, which is less than x. 1 minus 1 is 0. Very simple as that. So now, let us multiply 2 by the denominator. we are going to have my duster. Wow, can't find it. We are going to have x less than x plus 1, or here is 1 plus x. So x plus 1 is the same as 1 plus x times natural log of x plus 1 less than 1 plus x times x, as we have there. So let's arrange this. This is bigger, followed by this, then that. So we have x times natural log of 1 plus x is bigger than natural log of x plus 1, which is also bigger than x. And that is to be shown. Wow. Yes, this is my duster. Now, the second part. Hence, show that natural log of 1 plus x is greater than this. Now, let us take this part. From this part, we have natural log of x plus 1 to be greater than x divided by x plus 1. Now, natural log of x plus 1 is greater than x times 1 divided by 1 plus x. X plus 1 is the same as 1 plus x. And for this 1 divided by 1 plus x, we can use the power series to expand this. And the power series expansion for this is summation from n equal to 0 to n equal to infinity, x to the power n, where the absolute value of x is less than 1. Very, very simple as that. So, this is for x to the power. This is the power series for 1 divided by 1 minus x, right? So we are going to use it to derive for 1 plus x. So, for this one, if n is 0, 1, 2, so here, for 1 on 1 minus x, if n is 0, I'll have 1. If n is 1, I'll have x. If n is 2, I'll have x cubed. If n is 3, I'll have x to the power 3. And if n is 4, I'll have x to the power 4. And it will continue. So, I need positive here. So what do? So in place of this x, I'll put there negative x. So I'm going to have 1 divided by 1 minus this minus. Then this x is now negative x. So I have 1 divided by 1, negative times negative is positive x. So this implies that whenever I see x here, I'll put negative x there. So I'll have 1, if I put negative x here, to be negative x. If I put negative x here, to be plus x squared. If I put negative x here, it will be minus x cubed. Plus, then it will go on. Very simple. Sure? Yes. That is very, very simple. So you put negative x here, you get negative x. Put negative x here, you get positive. Put negative x here, you get negative. Put negative x here, you get positive. Then you continue. So now, we have natural log of x plus 1 greater than x times 1 on 1 plus x. And now we have this to be x. 1 on 1 plus x is now this. So we put it here, 1 minus x plus x squared minus x cubed plus blah, 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 blah. So this is still greater than x minus x squared plus x cubed minus x to the power 4 plus as our natural log of x plus 1. That is what we have there. Very simple. And that is to be shown. And it's proved. So this one, I've not done video on it. That is power series expansion. I've not done video on power series, but we have that one there. You may meet it later, right? So we just quote it and then use it. Very, very simple. Now let's come to the last part. So we are saying that as x approaches 0, natural log of 1 plus x over x also approaches 1. How do we show that one? We will show that one by using which parts of our proof? Yes. Which part will help us to prove this? Wow. Okay, I think where do we end? Okay, this part will help us to prove that. Yes, this part will help us to prove that. So let's take that part. So if you consider x divided by x plus 1 less than natural log of x plus 1 also less than x. Now, if we divide through by x, you have 1 on x plus 1 less than natural log of x plus 1 x less than x. Remember, this x is not inside, it is dividing everything, like what we have here. Wow. So, this will be 1. We divide, this x will go and this x will go, and we'll have this. So let's take the limit. We take the limit of 1 on x plus 1 as x approaches 0, also less than the limit of natural log of x plus 1 x, also less than the limit of 1. Then it means we are using the squeeze theorem. We are just squeezing this inside. So that is the squeeze theorem. So we are squeezing it, huh? Yes. So let's squeeze. As x approaches 0, as x approaches 0. So here, the limit as x approaches 0 of 1 is equal to 1. You get that? Now the limit of a constant is the constant. And the limit of 1 divided by x plus 1 as x approaches 0 is also equal to 1 divided by 0 plus 1, which is equal to 1. Wow. It means that we are squeezing this one, 1 less than the limit of natural log of x plus 1 divided by x as x approaches 0. Wow. So this clearly shows that the limit as x approaches 0, natural log of x plus 1 divided by x is also equal to 1. Wow. Now, how do we remove the limit? So let's move here. So, this is a continuous function, right? And natural logarithm is continuous on its domain. So we can put the limit here and bring the natural log outside. So we have the natural log of the limit wow. Yes, Lord. Okay, we can make use of this. Yes, we can make good use of this. So let's move on before. So this one is the same as the limit as x approaches 0, 1 on x, natural log of x plus 1. Wow. And this is the same as the limit as x approaches 0, natural log of x plus 1 equal 1 on x equal to 1. Oh, we have to prove that it's equal to, it approaches 1. So let's clean this one. So what do we do? So here we have this one, then you put this one there rather hand. Now there's the limit as x approaches 0, x plus 1 on 1 on x. We have limit as x approaches 0 of x plus 1 to the power 1 on x to be equal to e. So the whole of this equal to e. So you're going to have natural log of e. The natural log of e is 1. So this clearly shows that as x approaches 0, natural log of 1 plus x divided by x also approaches 1. Thank you for watching. Please kindly like, subscribe, share, and leave your comments.